Welcome back. It's been a while since I received some PCBs, and I know these are PCBs because they're from JLC Electronics, and that was of course because of the coronavirus and before that the Chinese New Year, but they're back up and running, and I thought I'd invite you to join me as I unpack these. I'm also trying out something different. I have 3 cameras set up. One's over there, and one's over here. And I thought I might switch that up in post-production and switch between different cameras. But I'm not really sure how that's going to work out. And by the time you're watching this video, you probably know. Now this came in 2 parts. Let me grab the other one. This is the stencil part of it, and again it's quite big. It doesn't even fit in this view. I think I got it wrong again. I keep getting my stencils wrong. I think I order a nice smallish stencil, but they keep ending up really big. But first let's see what's in the box with, I think, our PCBs. There we go. No, there we don't go. Still some tape here. Some more tape. Oops, bumped into the camera. Straighten that out. A big thumbs up. That's funny. Are these stickers or something? Oh no, they're little of these sticky notes. Well, we'll check these out later. Let's get everything out and get the box out of the way. All right. So there are 4 PCBs, and let's just start with this one. Ah, come on. So you've might already seen this, well, not exactly this one, a board very similar. It's the MiniAmp in a kit form, and I've sent this off to a few friends and they gave me some good feedback, and I changed one thing, and that is before I'm going to put them up on Tindy. And that is the old board, I don't have one here right now, had a 9-volt battery connector soldered directly to the board, and that is not a good connection. I solved that myself by putting a dab of hot glue on there, but I don't expect everyone to do that, so I made a footprint, or I imported a footprint for a JST connector. And my idea is to get some JST connectors and solder them to the 9-volt battery connector and supply them with this board. There's another update, and that's on the back. There is my web address for the documentation. There's a QR code, and of course it's a new version. And I've ordered, I think 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I ordered 15, so I hope these sell, because otherwise I'm stuck with 15 of these kits. I am gonna pre-pack all the kits, and when they do I will release another video telling you that they're up on Tindy. Let's put these to the side and get the next. They're really well wrapped. Come on. All right. Before I... Come on. There we go. Alright, before I can show these off, I have to do something else, and that's open these, because these are the original design. These are, wait, let me grab something else. These boards are this. This is a UPDI programmer I made, and it's on a breadboard and it's not really neat. So I thought I'd make a PCB for it. And the idea of this is it uses the Atmega 328P with the Eltangus JTAG to UPDI library and an FT231 USB to serial chip, and that way I have a small programmer that will just plug into my laptop or computer. There's room for a USB A type connector, and then this socket will fit in there, and these are all surface mount components, well, except for the connector, and I also exposed some pads on the other side, and also some room for some headers, so you don't have to use this ZIF socket. And just in case somebody else wants a UPDI programmer, well, if this works, of course, I first have to test it. Works on the breadboard, but I don't know if I made any mistakes on the PCB. But these are all surface mount, and let's move this out of the way. These are the same, only a bit different. These are all through hole. So this is a bit easier to solder. I use the same components. The difference is that, well, first of all, it's all through hole, and the FTDI chip, the FT231, that's also available in a SOIC. I keep saying SOIC, but maybe it's SOIC. But then again, you say DIP and not DIP. So I'm going to stick with SOIC, which is doable by hand if you have some patience. Don't drink too much coffee before you start soldering. This is perfectly fine. So now the next thing I have to do is assemble these and test them out. And the last batch of PCBs is a new version of the Dom Tower PCB. There are a few changes I made. First of all, I've changed the size of the, let's get something to point with, the size of the LED footprint a bit, so it's a bit more easy to solder, so the pads are a little bit bigger. I've labeled the pads that are exposed with a V for VCC, a G for ground, and a U for UPDI. The other change I made is that there's a switch on board Previous version, I have that over here. This was only, you could only turn this off by unplugging the power to it, and now there's a way to turn it off without actually removing the USB cable. The other thing I changed is the vane on top. So the one on the right is the one I designed first, and I actually didn't know whether this was strong enough to not break. So I didn't spend much time in designing the vane. It turns out it actually is quite strong. I've dropped this a few times right on its vane and it's perfectly fine. So I've spent some time designing the vane, some extra time, and as you can see it's now more like a vane that you usually see on church towers instead of a star, which made it kind of look Christmassy, and that was not the plan. So a redesigned Dom Tower. I'm also printing a stand for it, which is on this one. This is not the final design, but this way it will stand up straight. You can plug in the USB and you can access the switch from the right, turning it off and on. These I haven't designed to, well, let's get rid of these. These I haven't designed to be like a product I'm gonna sell. So I don't have a lot, I have actually just 5 of them. But some friends and family are quite interested in these, so I'll probably just make them for them and give them away as gifts. Let's also open up this, what I believe to be the stencils, for just one. I think I only made stencils for the, well, not this one. This one, of course. I only think I made stencils for this one. But it's really quite heavy, so maybe there's something else in there. Let's try and open this up. Oh no. They taped over the plastic thing that's there. This is going to be a pain to open. Oh, there we go. One side is enough. A different color. Normally they're brownish. This is more grayish. Actually, I like this color. So there's the stencil and me. Hi. And you can probably see what has gone wrong. These boards have surface mount components on both the front or the back. Actually, this is the front, but on both sides. I was planning to do just these 3 resistors by hand and use a stencil for this side, but I guess I didn't specify that I only wanted a stencil for one side. So now I have a dual stencil with the front and the back, and on one part of the stencil there's only 6 holes for 3 components, but it will work. I'm gonna assemble these as soon as I can, probably right after I'm done shooting this video, because I can't wait to see if it actually works. So, a fresh batch of new PCBs, and they smell great. I hope they also work. I'm gonna do that right now start assembling them and start testing them. Thank you so much for watching. A thumbs up if you like the video. Hit the subscribe button and also the notification bell, and I will see you next time. Thank you so much for watching. Bye bye.